Hi, Devin.
Hi.
All right, today we're going to play a Valentine's game because
Okay.
it's close to Valentine's Day.
Yeah.
Are you excited?
Yeah.
Okay. So we've been working on multiplication.
Mm-hmm.
So this is going to be a multiplication game called Heart to Heart multiplication game. Okay, you ready? Before we do the game, I want to teach you about how to use the game board. So we're each going to take turns flipping over cards. So I'm going to flip over, let's say I flip over a 4 and a 3. All right, so I can use these. One of these cards is going to tell me how many groups I'm going to make. And then the other card's going to tell me how many candies go in each group. All right, so we write the expression. Let's say I do 3 times 4. In multiplication, when I write a multiplication expression, what does the first number represent? Say it louder. Groups. So the first number in this game is going to represent the number of candy dishes. So how many candy dishes did I use? 3. So I have 3 groups, right? Because I'm going to put my candy hearts in each group, okay?
Mm-hmm.
So this is my first group, my second group, my third group. How many candy hearts do I need to put in each group?
4.
4. So let's put, can you do that for me? So does this represent our story?
Mm-hmm.
So we have 3 groups
A 4.
of 4 hearts. So how many total hearts? Finish off your equation here. How many total hearts did we use?
12.
12. How did you know that?
Because 4 plus 4 plus 4 is 12.
Okay, so you did repeated addition?
Mm-hmm.
All right, so finish your equation, right? Equals. Good. So to play this game, you have to use your product, which is which number? Which number is your product? Is that your product?
No.
Is that your product?
Yeah.
You sure?
Yeah.
You confident?
Yeah.
Okay, you're right. Do you know what these are called? Our word wall's at home, but what are these called?
Medium?
Oh, that's subtraction. Starts with a F.
Factors.
Factors. Think like the multiplication facts,
I was
you know?
thinking division.
I think, well, subtraction, it has the word minuend in it.
No.
All right, so factor times
Factor.
equals,
Subtraction.
you're really going back to subtraction. No, what is the, it's a factor times a factor equals a product, yes. So we're using the products for this game. So we have to figure out where to put the 12. Can you just pick any heart?
No.
No, because there are numbers here. That means something.
Mm-hmm.
Okay, now I'm going to show you this before we play. I'm going to show you this because I want to make sure you understand this game board. So,
What? Wait.
why are you laughing?
How'd you know it was this?
I am magic. I had already typed out this and I actually drew a 3 and a 4. What do you think of that? Amazing.
No, you must have what?
I don't know. All right, so what does 3 times 4 mean on this game board?
Well, I guess this.
Why do you guess that?
Because it's circling it.
Is it circled? It's like put a square around it? All right, so what does that mean? What do you notice there? No, look at your expression And look at what I put a box around.
Like to the floor.
What for?
That floor.
Oh, so you notice that there's a 4 here. One of our factors is a 4.
Oh, and there's 3 columns.
Oh, okay. So there you see a 3. Now, you said the word columns. What direction is a column? Up and down. So are there 3 columns?
4.
Can you show me?
1, 2, 3, 4.
There's 4 columns. Good. And do you see, does that connect with your equation?
Yeah.
Okay, so you see 4 columns.
Wait, 3 group. There's like 3 rows of 4.
Oh, can you write that down?
What?
Write what you just said. What else do you notice about your equation and what I put a box around?
My U's kind of look like 4s.
You what?
My U's kind of look like 4s.
Yeah, they did.
What?
What else do you notice? You got distracted by your U. What else do you notice about your equation that you wrote that represented our story? What do you notice about that equation and what I put a box around?
It equals 12.
Oh, what equals 12?
All the hearts in the box.
You see 12 hearts there? How did you know that was 12?
I counted them like
You counted the rows? So you saw 4, then
8, then 12.
good. So write 12 hearts. So there's a total of 12 hearts. Where else do you see 12 hearts in your work? Exactly. Where else do you see 12 hearts in your work? Exactly. So there's 12 total hearts, 12 total hearts, 12, and there's 12 here. What is the word you used in 2nd grade for what I put a box around?
Group.
When you have rows and columns?
I forgot them.
Remember we took pictures of things around our house?
Yeah, I remember.
It starts with an A. A-R.
Array.
Array. Very good. Do you notice that array?
What?
Is that an array?
Oh, yeah, rows and columns.
Yes, which you used. You already used that word. So that's another vocab word, right? So Devin, the object of the game that we're going to play is to get 4 hearts in a row. So you're going to use your product to claim a heart. But it can only go in 1 heart, and it goes in a specific heart. So 3 groups of 4. Which heart would 12 go into? Do you have a guess?
Yeah.
Why do you think that one?
Because it's 3 groups and it's in the 4.
That's exactly right. Very good. Good guess. All right. So even though the whole thing, I wanted to show you, we're not going to be putting boxes.
Well, I knew it wasn't these because these are 2 and 1.
Mm-hmm.
And if it was like, and I knew it was like this one because it was in the 4.
Very good, Devin. All right. So if I did 3 groups of 4, I would put the number 12 in this one. So on our game board that we're going to be playing on, it's going to be blank, and we're not going to make arrays. but I want you to be thinking about the whole reason that 3 times 4 equals 12 is it includes 12 hearts here, right? But we're just gonna be claiming 1 heart, okay? But during the game, I might ask you, like, can you picture the array right there and draw your finger around it, okay? Now, here's my next question before we start playing. What if, instead of 3 times 4, what if I had done 4 times 3? Would that look the same, our model?
No,
Why not?
because there would be 4 groups of 3 hearts.
Oh. Okay, can you show me that?
Look at this.
What am I looking at?
It's still equal.
What's still equal?
The hearts. See, from last time, it's still equal because it's the same answer. It's the same thing, just switched.
Mm.
But the model's different because if you look at it, it's different. But in your mind, it's not.
So
So the answer is not different, but in the model is.
good. So the story's different.
Yeah.
So here I might have 4 kids
Yeah.
each get candy dishes, but how many hearts do they each get this time?
3.
3 hearts. But what happens if I had 3 kids? How many hearts did they get the first time?
4.
So they would get less kids, more candy. Can you write that equation on your board? This our new one for these hearts.
4 times 3 equals 12.
What property is that called?
Community.
Good. The commutative property of multiplication. So it doesn't matter if we flip the numbers, right? It still is going to give us the same amount of hearts total.
Mhm.
So here's my last question. Where would that number go? You said the first one went here, right?
Want to go here too?
Would it?
Yeah. Because nothing changed.
But you told me that the story was different. The model was different.
Yeah, but the equation wasn't different.
Is the equation different?
Yeah, but the answer's not.
So the answer's the same. What did you tell me about this line right here?
3 rows of 4 columns.
So 3 rows of 4 columns.
4 rows of 3 columns. So it would be, 4 rows.
So you said 4 rows, right? And how many columns?
3.
So I got 1, 2, 3. So do I go down here?
Yeah.
So 4 rows. But now in each row, I only have 3 hearts through 3 columns. How many hearts total do I have?
12.
Still got 12. Does that array look different from the first array?
Yeah.
Yep. So where do I put this 12? Excellent. Write it in there. So there's some strategy to this game that we're gonna play, okay? Because you could claim that heart. If you drew the numbers 3 and 4, you could claim that heart by making 4 times 3, or you can claim that heart by making 3 times 4.